So first I check that they're stacked up, right? X, Y, constant, they're stacked. But what happens right now if I try to add things together? Nothing's going to actually eliminate, right? So I'm going to look at this bottom row. What would be a good idea to multiply the bottom row by? 2. Because I notice if I multiply by 2, I get a negative 2x and a positive 2x. So I'm going to distribute my 2. So that would give me negative 2x. Distribute the 2, I'd have negative 10y. Distribute the 2, and I would have positive 40. And I'm just going to give that a light kind of strike through. So I know that I'm done using that middle equation, and now I can add them together. But something funny happens when I add them together. What happens? Both of my variables cancel out, gone, gone. So I get 0 on the left, but the right-hand side gives me, what, 64. So all my variables are gone. Does 0 equal 64? No. So what is the solution to this problem? No solution. If I were to graph these lines, what kind of lines would I actually have? Oh, very good. Start connecting the graphs with the actual solution. So we're on page 109. All right, I wanted to throw at you question number 6 because this one's lined up, but you actually have to multiply the top row and the bottom row by something different. And you could either choose X or you could choose Y. The Y values are a little bit smaller, so it might be easier for us to find our least common multiple. Remember I talked about counting by 4 and counting by 6, and that's the least common multiple? So like 4, 8, 12, 18, no, 16, 20. And then if I wanted to count by 6s, 6, 12, 18, 24. What's their least common multiple? 12. So what should I multiply this top equation by to get it 12? And what should I multiply the bottom equation by? How am I going to get the 4? Yeah, so positive 3. And what should I multiply the bottom equation by to get to 12? And actually, this one needs to come out maybe positive. This one needs to come out negative. So they add together to 0. So instead of doing 2, we actually want to do negative 2 across the bottom. See if you can distribute those and get all, how many multiplication problems is that? 1, 2, 3, 4, 5, 6. See if you can get, They might cancel out again. See if you can multiply out all 6 numbers, right? Distribute, 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 and let's see if we can come up with a conclusion. You might need a calculator. Some of these, like multiplying 18 by 2, 12 times 3. Maybe see if you have a calculator in your bin. Does anyone need a calculator? But did you see where we're actually back on this? Almost back on it. Do you have one in your bin? Does everyone have a calculator kind of nearby? In case you need to use it? Okay, there's an extra up here on that desk if you need it. Okay, so number 6 is going to be different than number 5 if everything cancels out. Let's see, in the top row, 18x plus 12y equals 36. That was me distributing the 3. So I'm just going to cross out the top row because I've already used it. The bottom row, negative 18x, negative 12y, and negative 36. And I'm going to cross that bottom row out because I already used it. So Evan is noticing everything adds up to 0, right? So I get 0, 0, and 0 on both sides. What's my conclusion for this problem? This time I got 0 equals 64, no solution. This time I have a true statement, 0 equals 0. So it's all the points on the line. It must be the same line on top of itself when you graph it, just multiplied by a different constant. How did the homework go last night? Looking at some of your work, it looks like even though sometimes you might have messed up the math and come up with a decimal, I think you've got the process of elimination, We just have to practice getting the algebra steps perfect to get to the right answer. So let's try, let me see. Why don't we try number 1 on the next page by elimination, but I'll help you get it set up just so they're on top of each other, because see how they're not lined up? If you notice that the 5y is reversed with the 6x, and in the second equation, the x is coming before the y, if something is on the same side of the equation, you can just reverse their order. So I could just change this to the 6x and the 5y coming second. So underneath this equation, I'm going to write 6x plus 5y equals 17. And I want you to see if you can try that one. So multiply through probably what? The top equation by what? What are we going to multiply the top equation by? -6, right? So that I get a -6x and a +6x. So see if you can multiply through the top equation, write it down here underneath, add them together, and solve for y. See if you can do kind of those 2 steps. Distribute it out, add them together, and solve for y. And we'll make sure that we have the right y value before you plug it in for x. Not, they're on the left side. All right, so I'm just going to do that step and make sure we got to the correct value. Let's see, -6x minus 12y equals -24. -6, -6, -6. Okay, so I did that equation. Is that what you got? So now my x's are gone, and it looks like I get -7y here, and that's -7 as well, right? So y must equal +1. Did you get that as your y value? +1. Y equals 1. Okay, now take that 1 and you can plug it into either of the equations and see if you can get what x would have to be. See if you can plug it in and get what x would have to be. Maybe I have enough. I wasn't sure if I had enough markers. All right, what do we get for our x value? So I'm going to plug the 1 in up here. So I get 5 times 1 is 5 plus 6x equals 17. So 6x would equal, it looks like 12 if I subtract the 5 to the other side. So x would have to be +2. And then it would be nice to write your answer as 2, 1 somewhere. I didn't leave a lot of room, but 2, 1 is my final answer. I was noticing on the homework, some of you went through all of the work and you got x correct and you got y correct, and then you flip-flopped the x and the y in the coordinate. So double check at the end that your x comes first, like alphabetical order, 2, 1. If you put 1, 2 on the quiz on Friday, you're going to lose points. And I don't want you to lose points if you did all of the work correctly. All right, let's try one more from this page. Why don't you try example 3? Can you do that one using substitution because it's already set y equals over here? Can you try to plug it in and do substitution on example 3? I know that some of you like elimination now, but let's remember how to do substitution and try example 3 for maybe a minute by yourself. So when I distribute, I get 6x plus 12 minus 6x equals 12. This looks like another kind of weird solution because 6x and negative 6x add up to 0. So I get 12 equals 12. So what conclusion do I make if my variables are gone, but I have a true statement? Good morning. All points on the line. All points. Thank you so much. All points on the line. All right. I am going to skip down to example 5. Oh, actually, let's do number 4. I know I skipped number 2. I'm not going back to that one. Look at number 4. There was one very similar. We're on page 109. There was one very similar on the homework that a lot of you skipped because you thought it was a harder problem. It's actually an easier problem. You don't want to solve this using substitution or elimination. You just want to check. If I put in 0 for x and 6 for y, does it work here? And does it work here? It has to make both equations true for it to be a solution. So can you check number 4 right now? Decide, does it work in the first equation and the second equation? Then it would be a solution. Now the true question is, I'm not good enough. Wait, we'll see. Well, I need to dig up a marker for you. Let's see here. This is page 109, the second page of that. Okay, can you read that off? Did I hit everyone? Everyone got a board? Oh, I need to get a marker for you. Oh, I've got to be able to find one more marker. I have a neon pink. I'm not sure how great it's going to write, but we can try. All right, let me see. If I plug in 0 and 6, that works, right? Because I get 48 equals 48. So that one worked. Let's see. If I plug in 0 here and 6 here, do I get that 6 equals negative 6? And that's not true, right? This negative sign is on the 0, so I can't make this a negative 6. So I would say it is not a solution. And it says explain why or why not. I kind of justified why it wasn't, but I'm just going to say that it doesn't solve both equations, right? It could solve one, but that doesn't make it a solution to the entire system. All right, let's do an application problem that uses elimination so we can practice it. Let's do number 5, and then we'll do some graphing with the whiteboards and some linear inequality graphing. All right, so this says on Monday, Joe bought 10 cups of coffee and 5 donuts for his office, and it cost him $16.50. I feel like nowadays coffee's what, $4 a cup or something? No, I don't know. It turns out the donuts were more popular than the coffee, so on Tuesday he bought 5 cups of coffee and 10 donuts, and he spent $14.25. How much was each cup of coffee? So our first step is, what do we want X to represent and what do we want Y to represent? So let's say that X is our coffee. We want to know what? How much? So it's really the coffee price, and Y will make the I'm going to spell it donut like Dunkin' Donuts. Donut price. I think spelling donut like that is actual English though, right? Dunkin' Donuts, they spell donuts wrong. But that's how we all spell donuts now, I feel like. All right, so write me an equation about Monday. What happens on Monday? 10 cups of coffee, so 10 X's, and 5 donuts, so 5Y, and he spends a total of $16.50. Write me the equation now for Tuesday. So see if you can put Tuesday into an equation the same way, and this will be a perfect elimination problem with a calculator because there's some decimal stuff. So try doing elimination on your own. Your Tuesday equation should just kind of be flip-flopped, right? 5x plus 10y equals 1425. You can either choose to eliminate on the top or eliminate on the bottom, right? Whichever equation gets multiplied by -2, you're going to end up eliminating that variable. So, like, for example, if I multiply the top equation by -2, I'll be able to eliminate my y values. So see if you can do the next step. Distribute the -2, add together the two new equations, and solve for x or y. Once you know x, the y would be hopefully easier to get because you'll just subtract from that total price. And this is like one of the hardest problems I could give you, where you have to set up the substitution or elimination problem yourself and get to the end. Give away my calculators. Let's see. Need a calculator. All right. -53. What's -33 plus 1425? What'd you get as a different answer to? This? That's fine. Did you multiply the top equation or you bottom equation? Okay, so you got y first. Okay, so $1.25 sounds like what the cup of coffee is. And it didn't come out to an integer this time, but you know, at a lot of restaurants, things aren't exactly $1. You know, they're probably more like $3.99 these days, but $1.25 for coffee. Some of you solved for donut first. That's fine, whatever you got for donut. So now I'm going to take my $1.25 and plug it back into one of the equations. So for example, like on Monday, I bought 10 cups of coffee. So 10 times that $1.25 is basically going to get subtracted from my total, right? 5 donuts, $16.50. So I'm going to subtract that. Wouldn't that be $12.50? 10 times $1.25. So 5y, see if you can finish it. What would one donut cost? I think this didn't account for inflation. I think about, you guys buy Levitt's donuts recently? They're like, are they $2 each donut or something crazy? Let's see, I get 5y equals, is it 4? So 4 divided by 5, 80 cents a donut. Did anyone get 80 cents? Who did the Y values first? So 80 cents a donut and $1.25 per cup of coffee. I think you're getting a bargain. All right, so I'm going to stop there on the elimination and stuff practice.